Hello, this is Aaron Kane, and we're doing Lab 9. Lab 9 was basically taking 1-chloropentane and mixing it with hydrochloric acid. We kind of wanted to know the mechanism that it was going to undertake, and then basically outline that. So some of my results, we used 2 milliliters of the pentanol, 3 milliliters of our hydrochloric acid. Our theoretical yield, that formula was actually given to us. So once you calculate it, I calculated 0.98 grams, which is supposed to be theoretically, if you were to do this experiment, that's what you're supposed to get. My actual was 0.71. So once I calculated my percent yield, it was 72.4%, so not that good. So possible human errors were, I don't know if I didn't shake vigorously enough. When I was basically taking out some of my solutions, and then drying it in the centrifuge. So there's the different possibilities for basically all human errors on this, and why my theoretical, or I apologize, percent yield was lower than I would have liked. The second part of this was you wanted us to kind of explain how you can tell if something is elimination, substitution. So this that we got in our lecture is actually what I use the most in determining it. So basically, when you're looking at the reaction and you're looking at the reactants, you can kind of tell from what the reactants look like what mechanism it's going to undergo. So the first thing I look at is right up here, is what carbon is it attached to, whether it's primary, secondary, or tertiary. Typically, if it's attached to a primary, it's going to undergo a substitution. If it's attached to a tertiary carbon, then it's going to undergo an elimination mechanism. But there are different possibilities. So let's say, typically in substitutions, if it's in a primary and you have a negative charge, that's typically always an SN2 reaction. Now there are examples where an elimination, depending on how big the group is, whether it's 3 or 4 carbons long, once you get into a real bulky or big chain, then you can see it undergo EN2. But typically, if it's primary and you're involving some type of net charge with a negative charge, it's going to undergo that SN2. So as you can see, you can kind of go through the different examples, but typically the tertiary, it's going to undergo an elimination, because then you get that carbocation. And then if you have a primary with a negative charge, or you have anything, a primary or secondary with a negative charge, you're typically going to undergo a substitution. Basically, you have your electrophile and your nucleophile. You have the leaving group that leaves, and then you have your other group attaching from the opposite side, and that's kind of where you get the substitution. It happens in one step. So basically, you have two things. One's leaving, one's connecting, all in one step, so they're just substituting for each other. Whereas the eliminations, the leaving group leaves, that causes the carbocation, and that's a multiple step. So you have multiple steps when you're in your transition state as well. So those are kind of the differences between a elimination and a substitution mechanism. Here's kind of how how to separate and look at the ones that you want to look at, and that's it for Lab 9.